Alright guys, so now we are going to talk about the section 3.4, linear and angular speed. So radian measure can be used to relate speed around a circle. So remember we have s equal r theta, and what we are trying to find is think about a point moving around a circular radius at a constant speed. Neither accelerate nor decelerate. So constant, neither accelerate nor decelerate. Okay, neither accelerates or decelerates. Should be a S. So speed equal distance divided by time. S for speed, T for time. With the angle will be defined by theta. That is the angle, as T is the time. When for the linear speed, S is for the distance and T is for the time. So I repeat, speed over equal distance divided by time for linear speed, and the angular speed, it's angle divided by time. Because I know that S, the distance, the arc length, S is equal to R multiplied by theta, I can easily understand now that the linear speed is equal to half theta divided by T, and I understand also that theta divided by T, it's omega, and this is how we are connecting the linear speed with the angular speed, knowing that the linear speed is equal to the radius multiplied by the angular speed. And so V equal R multiplied by omega. So let's try to practice a little bit. An object goes around a circle, radius 1.25 every 3 seconds. Find its angular speed and linear speed. So first of all, I know that the angular speed is equal to the angle divided by the time. But I know that the object goes around a circle of a radius 1.25 meters every 3 seconds. So the angle is going to be 2 pi and the time is going to be 3 seconds. Therefore, I end up to have 2 pi divided by 3, and so we have a value of omega equal 2.1 radiant per second. Now, for the linear speed, I know that V equal omega multiplied by R. Therefore, I end up to have V equal 2.1 multiplied by R, which is 1.25. And therefore now I end up to have a linear speed equal to 2.6 meters per second. Find the angular speed. Problem number 2, find the angular speed. By the way, I could also find the linear speed right here by saying that V equal the distance divided by the time, and the distance is equal 1 circumference, okay, divided by 3 seconds, which is 1 circumference is equal to the perimeter, which is 2 pi multiplied by R divided by 3 seconds. Okay, R equal 1.25, so 2 pi multiplied by 1.25 divided by 3, and that gives me also, of course, 2.66 meters per second. Now, the angular speed. For the problem number 2, we try to find the angular speed of a point on Earth. Well, I know that the angular speed omega equals theta divided by the time. Theta is one rotation divided by the time, which is in 1 day. There is one rotation per day, which is basically having a 2 pi angle divided by 24 hours, because 1 day equals 24 hours. That said, and that means that the rotation, the angular speed of a point on Earth would be equal to 0.262 radian per hour. Now, if I look at the linear speed of a point on Earth, v equal omega multiplied by the radius of Earth, v equal pi divided by 12 or 2 pi divided by 24. This is an intermediate calculation, so I want to take all the value, all the digit, and there is more digit than 0.262, multiply by the radius, which is 3,960 miles, and I end up to have a linear speed equal of 1,040 miles per hour. Okay? All right. Now, that was the calculation for a point on the equator. But do we have the same thing for Madison? Well, remember that if I draw, so now if I draw a picture of Earth, and Madison is right here, that was the equator. That is where we're having Madison. Okay, this is where we're having Madison. Let me do a proper M and a proper A, Madison. And so, obviously, my radius, if that is the axis of rotation, my radius is right there. This is the radius for Madison. And I must remember, I'm still going to use the red one. All right, so I must define this angle right here, and I know this angle. I know that Madison is 43 degrees 05 minutes north. So the other angle, the complementary angle, is 90 degrees. This angle right here, if I call this angle theta, theta is equal to 90 degrees minus 46 degrees 55 minutes. Is it 46 degrees 55 minutes? It is 43 degrees 05 minutes. 43 degrees 05 minutes, which give me an angle theta equal 46 degrees 55 minutes. Now, if I want to find the value of R, I'm going to use the sinus of this angle, because I know that is the radius right there. This is the radius of Earth. Therefore, using the expression of the sinus of the angle theta, I know it's going to be equal to the radius R that I'm looking for to calculate the linear speed, and I multiply that by I divide that by the radius of Earth. So I end up to have now a value of R equal to 3,960 miles multiplied by the sinus of 46 degrees and 55 minutes. Obviously, you will have to transform 46 degrees and 55 minutes, and we end up to have a R equal to 2,890 miles. Now, you have everything you need in order for you to find the linear speed. The linear speed V equal omega multiplied by R. V will be equal to pi over 12 because we're still having the same angular speed. 2 pi in 24 hours, pi in 12 hours, multiplied by the value of R, which is 2,890 miles, and we end up to have a 757 miles per hour. So we certainly can say that the people on the equator are having a linear speed bigger than the people who are not in the equator. All right, so let's try to do another example, if I may so. I will let you try the problem number 3, and I will work with you the problem number 4 and 5 on a different video because it's going to take me a little bit more time, and I want to spend at least probably 5 to 7 minutes, and I just have 4 minutes. So let's take a break and let's try to do a video for this section 3.4 part 2 in a few seconds.